Okay, welcome to our hopefully quick, review on logarithms from integrated 3. So go ahead and read this at your leisure up at the top. It basically just says we can translate logarithms and exponentials kind of back and forth. So when we take a look at the bottom here, I think the key thing is to take away the fact that those two are technically the exact same thing. It's just that one is written in logarithm form, the first one, and the other one is written in exponential form, the second one. But they're 100% equivalent to each other. And it kind of depends on the situation, which form you want. The next thing, too, is this is just a quick little location for you to fill in your squares and cubes. So just to make sure that you remember what these are. So if we want to go through, we know that this is 2 squared is 4. So hypothetically, this is one of the things you could look at here. So if we have 2 squared is equal to 4, which we know to be true, then we know that this can also be rewritten. So I would use this as an opportunity to kind of practice your rewriting. So we know that the base of the exponential is 2, which means the base of this logarithm would be 2. So log base 2. I'm just doing a quick translation. Then I would recommend that you do the same with the rest of them. The exponent itself is what your logarithm is equivalent to. And then whatever you're taking the logarithm of, that's what your answer was from your exponential. So just a quick little reminder of how to rewrite these. So what I would highly recommend you do is go through, fill these in, at least know your squares and your cubes and all of that. You need to be able to simplify these. But I don't know that me sitting here and filling that out for you is the best use of time. So highly recommend you go through and do it. The expectation is, yes, that you know these. So just so you're aware. Okay, if we go to the next one. So all we're doing is solving for x. And if you do take kind of a quick glance at all of these, so 1 through 15, they're basically set up in pretty close to the same format. So it really is just, can I rewrite? And then do I know how to solve from there? Or do I know what the answer is without actually rewriting it, because I am adept at translating into an exponential mentally without actually writing it down. So just keep that in mind. I'm going to go through this pretty quick. So we know that if you want to rewrite logarithm as an exponential, start at the base. So I'm going to do kind of like a jump across and then come back business. So you jump across, that's going to be the exponent on the 3, and then you go back inside to see what this is equivalent to. So we have 3 to the x is equal to 9. Well, we know what that is. That's x equals 2. Okay, the next one. Start at the 2, jump across, come back, 2 to the 8th. That's equal to x. And then we go through and calculate 2 to the 8th. And then 2 to a power really isn't too terrible. 3s, those can get kind of nightmarish. This one's not bad, though. This is 256. Okay, moving along. So start at the bottom, jump across, come back. So we have 5 to the x is equal to 125. Well, I know that 5 cubed is 125. So just kind of plowing through this real quick. So we have 5 to the x is equal to 1 over 25. Quick review of negative exponents. You don't want the 5, if it was in a fraction, the 5 would be up in fraction, whereas the 25 is in the bottom. You don't want them on different levels. So I'm going to bring up the 25. So to change location, remember we just changed the exponent to a negative, and then this is going to be 5 squared. Let's come over here. So this is 5 to the x is equal to 5 to the, in situations like this, you multiply the two exponents, and then we don't need the 5s anymore. Okay, next one. So we've got 7 to the 0 power. Anything to the 0 power is 1, except 0 to the 0, but your calculus teacher will talk to you about that. Number 6. So we have 49 to the x power is equal to 7. Rewrite them with the same base. If something doesn't have an exponent, give it an exponent of 1. This is another situation where you multiply. So we have 7 to the 2x is equal to 7 to the 1. We'll go up here. Don't need the 7s anymore. 2x is equal to 1. Divide. X is equal to a half. Now, you don't have to show all of this work. I'm going through it just to hopefully jog your memory on these. But if you know what these are without actually going through and showing calculations, then by all means. 9 to the half power is 3. Remember, a fraction exponent, the top is the power or the exponent, and the bottom is the root. So this is the same thing as 9 to the power of 1 inside the square root symbol. That's where I got 3 from. Okay, next one. This is going to give me 9 to the x is equal to 9 to the 5th. Don't need the 9s anymore. X is equal to 5. Interesting thing about logarithms also. So if we go back and take a look, the log doesn't have a coefficient. I haven't even dealt with any of those yet. But if you take a look at the base of the logarithm and the base of the value inside, if those are the exact same thing, it's the idea that inverses and let's try that again. Logarithms and exponentials are inverses of each other. So those are going to cancel. The only thing you're going to have left is the exponent. So no work necessary. You could just say x is equal to 5. Okay, let's keep going. So 2 to the negative 3 power is equal to x. Well, that's 1 over 2 to the positive 3 power. 1 over 2 to the positive 3 power is 1/8. So just a little bit of review of like fraction exponents, negative exponents, that type of stuff. Okay, if I look at this one, I'm not going to show any work on this one. I see that the base of the logarithm and the base of the value that's inside of the exact same thing, they're going to cancel. X is just whatever the exponent is. Okay, let's rewrite this one. This is going to give me x to the 4th is equal to 81. Okay, well, I don't need to match bases here. The x is actually in the bottom. So what number to the 4th power is 81? Well, that's 3. Okay, next one, next to the 4th is equal to 16. So we know that that's going to be equal to 2. Okay, so if we take a look at question number 13, this can be done a couple of different ways. This is technically an exponential right now, so I'm going to rewrite it as a logarithm. So if 3 is the base of the exponential, then that's going to be the base of the logarithm. Remember, we had to jump across the equal sign to get the exponent. And then whatever this was equivalent to, your exponential, is what goes inside. Okay, now if you look at this, we have log base 3 on both sides, if you read from left to right. If this is true, and it is, it's an equal sign, then the x has to match whatever the value is on the other side, which in this case is 7. So we have x is equal to 7. However, we didn't have to do it that way. If we do 3 to the log base 3 of 7, this is extremely similar to the one that I did on question number 10. The base of the logarithm, and the logarithm this time is in the exponent. Those are still going to cancel. You're still just going to get whatever value is left over, which is 7. Okay, this one, I'm not going to do a ton of work. I'm just going to write in the base that's missing. And if there's no base there, we know it's a base of 10. So that matches with that. That cancels. I get 7 is equal to x. Okay, then the last one here is 81 to the x power is equal to 3. Well, I know 3 to the 4th power, it's going to get multiplied times whatever's up there. Put an exponent of 1. I get 4x is equal to 1. Running out of space, looks like x is equal to 1/4. Okay. So up at the very top here, it's the same thing that was at the beginning of our notes. So, right, I'll put a little red box around this. It's the fact that those are the exact same thing. So I know, wow, come on. I know that if I have something written as a logarithm, I can translate it to an exponential, and vice versa. Just figure out what form makes the most sense given the situation. Okay, a couple of things I've written down for you. Again, stuff from integrated 3. Change base formula. You can use whatever base you want. Doesn't really matter. So, for example, I'll put an example in red. I can have like log base 2 of 19. Let's say I wanted log base 7 I'm allowed to do that. Like, just as long as the base is appropriate. So all you do is what was the base originally goes in the bottom, and what you were taking the logarithm of originally goes in the top. It's just a nice, neat little way to kind of turn it into something else that you need. And then basically the three properties of logarithms. If you want to add them, bases match, you're going to multiply when you pull it together. If they're subtracting and the bases matched, pull them together, you're going to divide. And then if you have a coefficient on the logarithm, you can actually make it the exponent. So those are the three basic properties of logarithms. Okay, so if we take a look at our condense into a single log here at the bottom, whenever you're condensing, you have to do things in a specific order. One, all coefficients must be turned into exponents first. So the first thing I'm checking is if I have any coefficients in front of my logarithms. And I don't. Those are all ones, so I'm good. I don't have to do anything there. Now from here, I know that addition turns into multiply, and I know that subtraction turns into divide. So you could do one step at a time from left to right. So we could do log of 5 times 7 minus log of 4. And then 5 times 7 is 35 minus log of 4. And then we know that subtraction really means divide. And that's our answer there. Like, there's nothing else to do. You're just condensing it into a single log. So you can go through and follow all of the steps, or you can recognize, maybe your teacher taught you this last year, you can recognize that if something came from a positive logarithm, that represents multiplication. Whereas if something comes from a negative logarithm, that represents division. So I'm going to do this problem again, but I'm just going to go straight to the log of fraction and just put everything where it goes. So this very first one, the 5, comes from a positive logarithm, which means the 5 is going to go on top. Positive logarithm, also 7. It's going to get multiplied to whatever was already up there. The 4 comes from a negative logarithm, so it's going to go in the bottom. Now, if I had another negative logarithm, I would put it in the bottom also. So I can go straight to the punch on this one without going through all of the different steps. You get the exact same answer. Question number 2, have to deal with coefficients first. There's a coefficient right there, so we got to move this guy up. So I'm going to copy down my log of y plus move the 2 up. So this becomes log of x squared. Okay, all coefficients are handled. The bases of the logarithms match. One logarithm. None of those logarithms are negative, so I don't need a division bar. They're all just going to get multiplied together. That's it. Okay, same thing with question number 3. And at any point in time, you're welcome to pause this video, see if you can get the answer, and then just come back and check yours against mine. Okay, so coefficients have to go up first. Oh, we don't want a box. So this is going to be log base 5 of, 16 to the half power is 4. Remember, power over root. Log base 5 of x squared. Logs match, bases match. They're all positive logarithms, so it's all multiply. That's it. Number 4, any coefficients? Not on the first one, not on the second one, not on the third one. There is one on the fourth one, though. So let's go ahead and move that up. And then just copy down what you have. So I've got log of 5 minus log of 3 plus log of x plus log of b to the 4th. No coefficients, all the bases on the logs match. I do have a logarithm that is negative, which means I need a fraction bar. Okay, let's go across. That log of 5 is positive, so it's going to go on top. Positive, positive. That log x is positive. It's going to go on top. It gets multiplied to whatever else is already there. This log b to the fourth is also positive. That's going to go on top. It gets multiplied to whatever's already there. Then this log 3 is negative. That goes on the bottom. And that's my answer. Okay, number 5. Same thing. I have a coefficient on the last one. So let's move this up. And I'm not going to move the negative sign up. I don't want negative exponents here. I just want the negative to tell me where I'm supposed to put things inside the logarithm. So I'm just copying down everything else that I have. Minus 3 squared is 9. I have negative logarithms. Okay, all the bases match. I need a fraction. Let's start grabbing stuff. So positive 5 goes on top. Positive 6 goes on top. I'm going to put a multiplication dot there. You're not adding these when you pull them together. That's it for positives. Okay, negative, we have a 2, that goes on the bottom, times 9, that also goes on the bottom. Okay, go ahead and clean this up. So this is log of 30 over 18, and that can be simplified. Log of, so it's 3 goes on the top, 10 times, here goes on the bottom, 6, that can also be simplified. And that's going to give me 5/3. Okay. Then we use logs to help us solve. So if an x is in an exponent and we cannot match the bases, then logs are an excellent tool to help us to rewrite it. Now, you can think of logarithms as a rewrite of an exponential, or you can think of logs as an operation, kind of like, I want a plus 5 on both sides. You're allowed to do that as long as there's an equal sign. You can think of logs as an operation. I want to log both sides. Okay, that's okay. You're allowed to do that as long as there's an equal sign. So it kind of depends on how you want to approach this. I'm going to do question number 1 2 different ways so you can see. So I see that the x is in the exponent. I cannot match the 5 and the 8. If I could, I would, because then I don't have to use logarithms at all. So what I'm going to do is I'm going to rewrite this. So one way is to rewrite as an exponential. Rewrite as a logarithm. So we can do log the base of this exponential is going to be the base of the logarithm. The exponent is what's across the equal sign. And then whatever it was equal to is what goes inside. That's x equals. That's an answer. It's a totally valid answer. You could also, so that's one of them. You don't have to give both. I'm just showing you a couple ways to do this. You could use logs as an operation. So that's another way to do this. So if I have 5 to the x is equal to 8, and you're like, well, if there was a logarithm in front of that 5, then I could use the third property of logs that says exponents can come down. So what you can do is put a log on each side. And you can use whatever base you want. If you want to use a base 2, use a base 2. If you want to use a base pi, use a base pi. It doesn't matter. Now that logarithm's there, now we can bring the x down. So this is x times log 5 is equal to log 8. And then to get rid of multiply, we divide. Those cancel. There's x. X is equal to log of 8 over log of 5. This is the exact same answer as the other one. Actually, you could have just done change of base formula too. That's ultimately what happened, just a base 10. It doesn't matter which one you give. They're both correct. Okay, question number 2. Let's go ahead and rewrite this one. So I'm going to start at the x, an exponent. So this is going to give me x cubed is equal to 125. Okay, there's no x in the exponent here. All you have to do is cube root, and you get x is equal to 5. Okay, again, at any point in time, just pause this and see if you can go through and do this. If there's no base, put a 10 down there. Let's rewrite it. We got to get the x out of the logarithm. Okay, now for me, when it comes to exponents, I expect you to do exponents that are reasonable. Like 10 to the 7th, sure, that's a 1 with 7 zeros. 10 to like the 19th, that's ridiculous. Don't write out 19 zeros. But 7, I mean, that's okay. If it was like 3 to the 7th, no way, because you don't have that trick with 10s that you do with 3s. So this would be 1, 2, 3, 4, 5, 6, 7 equals 3x, and then just divide by 3. So 1, 2, 3, 4, 5, 6, 7 divided by 3. That's it. Okay, the last one on this page. Let's rewrite this. We got to get the x out of the inside of the logarithm. So this is going to be 4 to the negative 1 is equal to x minus 3. Don't leave it as 4 to the negative 1. That's 1/4. Remember, negative exponents tell you to basically change location in a fraction. So currently, the 4 to the negative 1, the 4 is in the top of a fraction. Just move it to the bottom and change the exponent to positive. Add the 3. If you have a positive 3 and a positive 1/4 and all you're doing is adding them, then just add them. Just push them together. Okay, moving on. Question number 5. So now we have multiple logarithms. We need to be able to pull those logarithms together. So this is where our properties of logs comes in. And then we need to assess from there. Like, do we have a logarithm on the other side, or do we need to rewrite it? Like, what do we need to do to get to the x? Remember, you're just trying to get the x by itself. So I'm going to condense the left-hand side. I'm looking for coefficients. There are no coefficients. The bases of the logs are the same. And it is a division problem because they are subtract. Okay, one logarithm. This is much better than multiple logarithms. I still have to get to the x though. So what I'm going to do is I'm going to rewrite this as an exponential. So I'm going to put my little base down there of 10 because if there's nothing there, we know it's a 10. I'm going to rewrite it. So it's 10 squared is equal to 6 over x. 10 squared is reasonable. That's 100. 6 over x, put a 1 under this, cross multiply. Whoop. So we'll get 100x is equal to 6. And then divide by 100. We get 6 over 100. If you want to simplify it to 3 over 50, that's fine. If you want to turn it into 0.06, that's fine also. Okay, next one. No, same idea. We have our variable, which is m this time, is inside a logarithm. We have to be able to get rid of the logarithm so we can get to it. But you don't want multiple logarithms. You want to crush the two logarithms together. So I'm going to condense. So I'm going to take my 2 and I'm going to move it up. So this is going to be log base 4 of 7 squared, which is 49. Log base 4 of m is equal to 3. Okay. Both the bases of the logarithms are the same, and they're both positive, which means it turns into multiplication. Okay, rewrite. So I have 4 cubed is equal to 49m. 4 cubed is 64, that's reasonable. Divide by 49. I'm going to get 64 over 49. Let's get rid of that errant mark, is equal to m. Now, one of the things, too, to keep in mind is that you can never take, like for logarithms, you can't have log of 0. That's not possible because of the rules of exponents. And then you can't take log of a negative number. So I am going back and I keep checking, like, okay, if I take a look at this and I plug this in to my m location, am I taking log of 0 or log of a negative? If I am, I cross it off. It's not going to work. But with all of these, they've worked so far. So I am checking them just to make sure. Okay, let's take a look at the next one. Okay, I've got logs all over the place this time, which is fine. Let's pull the left side together. So this is log of, so I'm going to do 5 times 8. And this is log of x. Okay, so 5 times 8 is 40. Now, let's stop and look at this. We read from left to right. You have a log and a log. So coming in from the left of each side of the equal sign. If those match, then you've satisfied one part of it. You just now satisfied the next part of it. The green parts have to match. So I'm just going to go straight to 40 is equal to x. I couldn't do that before because there wasn't a logarithm on the other side. It's not like they looked equivalent already. I had to do some work to try to get them to be equivalent. This one, straight to the punch. I think that's it. I hope that helps and kind of reminds you of the stuff we did back in Integrated 3.